Thevenin equivalent circuits. The Thevenin equivalent circuit can be defined as a simplified form of a complex electrical network comprising a voltage source, a series resistor, and the load. This simplified circuit is used to analyze and understand the behavior of a complex network from the perspective of a single load. This allows engineers to easily analyze networks with sources that are not in series or parallel, as well as reduce the number of required components. Based upon the Thevenin theorem, which states that any linear electrical network with voltage sources and resistors can be replaced by a single voltage source in series with a single resistor. This resulting circuit will produce an equivalent voltage and current to the original network when connected to any externalized load. To determine the Thevenin equivalent circuit for a given network, we must first remove the portion of the network where the Thevenin equivalent circuit is found. This may require the load resistor to be removed from the network for now. Next, we must mark the terminals of the remaining two-terminal network before calculating the Thevenin resistance by setting all sources to 0, then finding the resultant resistance between the two marked terminals. Next, we must calculate the Thevenin voltage by returning all sources to their original position and finding the open circuit voltage between our marked terminals. And finally, we must draw the Thevenin equivalent circuit, replacing the previously removed circuit between the terminals of the equivalent circuit. Now let's work through an example. Remember, we must first identify the terminals of greatest importance. In this case, removing the load, creating an open circuit. Next, we must calculate the Thevenin resistance by shorting all voltages and opening all sources of current. Note how the resistances in this example are in parallel from the viewpoint of the open circuit. Hence, our Thevenin resistance is equal to 2 ohms. From here, we measure the voltage across our two terminals using the voltage divider rule to find our Thevenin voltage, giving us a voltage of 6 volts. Lastly, we display our final Thevenin equivalent circuit, showcasing our calculated values, placing the load back in between the terminals. As an additional note, a Norton equivalent circuit is similar to that of a Thevenin equivalent circuit, defined as a simplified circuit, however, instead consisting of a current source and parallel resistor.